All right, so we had a visitor come in for the first half hour or so of class from academic advising. For those watching the video later, walking through the process for registering for summer and fall classes. Make sure you do that sooner rather than later. If there has to be a certain number of students register for a class in order for it to run. So if everybody waits to the very last minute and tries to register the week before, there's a good chance the class will have already got canceled because it looks like people aren't interested in taking it. That does happen sometimes. So registering sooner rather than later is good. So we're into module 5 now, which means we're past the halfway point. I have to submit midterm grades, which is just a formality. I'm pretty sure the only people that look at the midterm grades are the academic advisors. And then if the midterm grade doesn't look so well, though, the academic advisor might reach out to you. But the midterm grade does not impact anything. It's just something for the long-term record keeping. So I have to submit something. So at some point this evening, tomorrow morning during my office hours, I will just open up the grade book and turn in whatever's in there. I think everybody is doing quite well. Everybody that's turned in work in the class so far is doing quite well in the class. So it shouldn't be a problem. But if you see something about the midterm grade posted, it doesn't, like, the midterm does not count on your GPA or anything. So that's just a technicality under record keeping. Does anybody have any questions before we get started into our next couple topics? A couple things to go over today. Okay, so the next thing I want to talk about, there's a couple things to cover still. You might remember we had those 4 constructs. They're coming back to those. Let's do a quick recap of where we're at. We talked about there's 4 types of tools we need to solve any problem. And that's what we use our technology for, is to solve problems. So we're going to examine these tools in order to put together algorithms. That's our main focus of study here again, the developing algorithms, the steps necessary to accomplish a task, spelling it out in enough detail a machine can carry out those tasks, because machines can't infer or figure out anything on their own. There's 4 types of tools we need to solve any sort of problem. Some sort of sequential tool, an order that we can walk through, a sequence, a definite beginning and a definite end, so we know when our problem has been solved. But we need a tool to take us through a sequence that falls very naturally in programming languages. It's not like English, but we still use the same symbols we do in our normal English spoken language. So in general, the way we write our code from left to right, top to bottom, is the sequence programming languages are going to go in. Then we need some sort of way to make choices along the way. Selection structure. So that's what we were looking at previously. Then the last 2, what we're getting into now, we need a way to reiterate steps. And I use the words reiterate and repeat slightly different, kind of like the way I use complex and complicated during our lectures. When I say repetition, I mean exact repetition. Nothing changes, doing the exact same thing over and over and over again. And I'll use reiterate to express repetition with variance, so slight changes. Examples like the problems mowing the yard. So our sequence is to push a lawnmower all the way around the yard until all the grass is nice and short and the same height. So selection, where we start at, and a lot of choices to make there for that problem. But you're pushing a lawnmower and mow a strip of the yard. Repetition would be come back to the beginning and push the lawnmower down that same strip. Come back to the beginning, So whenever I use the word repetition or repeat, I'm talking about the exact same thing. Usually we need to do that repetition with a bit of variance in it. And I'll use reiterate to express the difference between them. Because sometimes the exact same repetition is the part we want. So variance would be like you push the lawnmower down a strip, get one strip of the yard mowed, then you turn around and move over and push the lawnmower down the next strip. So you're repeating the process of pushing the lawnmower down a strip of the yard to get the grass cut, but you're varying it slightly so that you're cutting a different strip of the grass every time, and eventually the yard gets mowed. And then our fourth tool, a little harder to put a good clean word on, but I usually go with invocation. Invoke something. Basically, this means we know we need a way to step out of our sequence, do some other stuff, and come back to the exact same spot where we left from the sequence. So we still need to talk about these two tools. And I'm going to start talking about the fourth one first. And remember, our main goal from this course is we started with this big picture of things you probably know about computers, right? Computers take in input, stuff happens, and then they send out output. And we've kind of started filling in some of that stuff happens bubble, right? We have our volatile memory where we might store some values. And once we have some values stored, we can come over and make a choice about what to do with those and go through one or two different paths and do different types of processing on each path. Something different happens, and then both of the paths lead to some variance in output. So we're starting to fill it, still working on filling in that picture. Haven't drawn in a moment, so I want to put that up there, but that's kind of where we're at. We still need to talk about these last two tools. So that's what we're getting into next. Is it okay if I erase this? This was just some recapping things, looking at where we've been.
For sure.
Yeah, our goal here is to make that big bubble. The very first day of the semester, you might remember that bubble just said stuff happens between the input and the output. We want to start filling that in. So the first thing I want to look at is actually what I've put here is number 4 on those constructs, the invocation one. So you've surely noticed by now that when we're developing programs, we often use a lot of pre-built segments, right? Like, well, in those Python examples, in the out of the textbook, if we need to get some input from the user, how do we get the input? It really just takes one word, right? Input, put in some sort of prompt.
Don't we have to put some type of float in there for some of those for input?
Some of it, yeah, because it's coming from, this is going to come from the keyboard. It's a
Yeah, and then you're gonna put in the first statement.
yeah, but
And if you ask for repeating statements, then you just put this similar type thing and
and then we put that somewhere, but we did not build this, right?
no.
That already existed. We just asked for it.
Yeah, but we did create the wording within of just
Yeah.
stating gimme,
Yeah.
like gimme the pizza
or-
now.
Over in our flowcharts, we
Yeah.
have this symbol. When we went to do the graphics, we would put open graph window, which I didn't leave myself enough room to write there, but I'll put ... We say open graph window. We didn't write that. We didn't have to define what a graph window is, right? We didn't have to set up some sort of way to reference every single pixel on the screen so that we can start drawing pictures on it. Somebody already built that. It was already made, ready for us. They're not full programs themselves, right? That thing we asked for to get input in Python is not an entire program. It's just a little segment, a a sub piece of a program. And just a few instructions that are going to go together lots of times. Every time we need them, they're going to go together. We also saw way back on day one that whenever we have a single data point we need to store, like the number 3 or the word hello or anything like that, maybe even just the value true, we want to keep that around to reuse it with a word that makes sense in our current situation. So we can just assign those to some value. Stick I'm abbreviated on the board. Usually we spell that out when we're writing code because it's easy to type. Oh, use single letters on the board, but we can store that somewhere, and then any place we need a value true, we can just say B, or we can say not B if we want false. Any place we need to use the number 3, we can just say X, and we use X over and over and again through our program. And if we were like, oh wait, that it wasn't supposed to be a 3, that was supposed to be a 13, we can change it real quick, and then every place we use X is automatically going to update because we just had a reference to that data. We stored the data somewhere, and then we created a way to refer to it. And basically, what this is leading into is single data points aren't the only thing we can store a reference to. And yeah, so the first thing we're going to look at here beyond storing a reference to a single data point is store a reference to a set of instructions. So that's what these are, our input over in Python or our open graph window in Raptor. Those are just things that refer to a set of instructions that already go together. Not necessarily an entire program themselves, right? It's not a complete program. It's a blank slate ready to be included in a program, but it's some pre-built set of instructions that we can use. And basically all that happens with them is we create a reference just like we did with single data points, only instead of to a number or a word, our reference keeps track of a bunch of instructions that we can reuse over and over again.
Is that why in APIs it's easier to implement? Like if you have an API, it's easier to program for a certain service or an application because you can implement those microservices, and those microservices can be those programs that you refer to.
That's what an API is. So
oh, an API is yeah, it's a microservice itself. Yeah.
Application programming interface.
Mm-hmm.
Python is an API. Raptor is an API. All our programming languages, a programming language is an API.
Okay.
The only thing that's not an API would be as a machine language. If you were working directly in ones and zeros.
Okay, so what does it mean when somebody says like, I use Google's API to use their voice assistant?
That is a programming language.
Itself, it is?
Yeah. Yeah, that's the programming language, and they pre-built a bunch of reusable code. So let's kind of look at something here. I'll go in this way, and we'll lead into functions because
cool.
I need to stretch it out by 10 minutes, so we won't be at a good break point into the thing, because this is only going to take about 10 minutes to talk about, which would be a little early for a break. And if we jump into the next topic, it won't leave us a good break point. So what an API is application programming interface. It's a way for us to interface with the machine. And that's really what a programming language is altogether. Usually when we say that, we're talking about subsets of the programming language. But if I go in here to where Python's installed on my machine, since we've looked at Python some, oh, that's not right. I have to go in users first. There you go. So here's where Python's installed on my machine. So what Python really is, it's an interpreted language. So here's the interpreter. That's the thing that knows a few keywords. There's a few keywords we can use. Input is not one of those keywords, by the way. Let me pull that up. These should be in alphabetical order, right? Yeah.
And this is the repository, right? And this is where it fetches the extra stuff that it looks
Oh,
for.
this is the language itself.
Okay. Sorry.
Repository is where we would keep things that we build with it. So you'll notice all these are Python scripts. So I passed it. I'm looking for something called keywords. There it is. Oh, I didn't mean to run that. Let's see, open that with Adam. So this list right here, here are the things that the Python interpreter knows. So the Python interpreter can do things with this list of words: false, none, true, and, as, assert, async, wait, break, but kind of a short list. You'll notice the input's not one of them, but these are the words, and along with these keywords are operations, the math operations: add, subtract, multiply, divide, modulus, exponents, those things we've seen. It's a very, very short list that the interpreter actually knows. Then what it does, some of these would be a mess to look at. So then what we think of as the language, this is what the API part is. People already wrote a bunch of things in with those keywords, things that can be done. So I've opened up calendar here. That one's not as hard to read as some of them. So one of the keywords is import. So that's referring to other scripts that were written. Few keywords. And see, here's some assignments, like we know what to do. We're gonna, since we have numbers and words for our months, we're gonna go ahead and set them up, make January 1 and February 2 and so on. The rest of it fills out automatically later. That part of the code looks complicated, but assignments like we've seen. Then some objects, and then finally down here is some pre-built things that we can ask for. A way to, that way we don't have to do this again. So like this is just, if we need to know whether a certain year is a leap year, we can just ask for this thing that was already built. So that's usually what's meant by API, is all of these pre-built things with, and that is also what our programming languages are. Has a short list of keywords and key symbols that the interpreter or compiler knows how to deal with. And then we just build up things to do with those keywords and key symbols. We write programs with those.
Okay.
And then once they're written, they're reusable. So somewhere deep down, and I didn't want to open that one because it's a complete mess, but that one written on the board, the input, it looks exactly like this. There's the keyword def for define, something called input, and then some stuff over here inside of parentheses, which is what we're getting ready to talk about. And then all of that stuff is pre-built. So that's what an API is, which is really what our programming languages are.
It's implementing these pre-built algorithms or pre-made things into our software to solve problems.
Sorry, I didn't hear the last word, Tyler.
Oh, to solve problems.
Yes, yes. Problem to show with nice pictures and colors and be formatted really nice. So that's what we're going to look at next, because really what those are is it's a way to refer to a set of instructions the same way our variables would refer to a number or refer to a word. Kind of the next step up. We've seen instructions like that, and we've seen creating references to our data, but we can create references to instructions as well without making them a full program. The biggest advantages are reusability, such as the little talking about the APIs there. That stands for application programming interface. So technically anything that's not machine language is an API, but usually we refer to it to things like all those functions in Python that are pre-built, ready to go for us that we can use, so we don't have to build everything ourselves from scratch. Or Google just does everything they do, they make public, they keep public. So you can pretty much use anything that Google has created. So they have their Google API is an extension of that beyond one language, is when they combine a set of instructions into reusable form, they go ahead and do it in every language they know about, which
Okay.
Google obviously
So
knows about every language.
they
That
can
way
make an
everything
API
is
for a
so
specific language as well, like, or the language that the thing is programmed in. So like Home Assistant, they're using Python 3 and they make an API for Home Assistant for Python 3 that you can access and code for Home Assistant with Python,
yes.
right?
Yes.
Okay,
It's like
nice. All right.
another, we often use the word, well, the word changes language to language, library or package or module, depending on the
Okay.
language, we call them different things, but it's something we
Yeah.
can bring in and use in our code.
Okay.
For your,
Thank you for the
your main
explanation.
code. We don't have to start from scratch. That's the biggest thing about computers. We don't have to start from scratch. And programmers have been working full-time careers for 80 years now. So there's a lot of stuff already built. We're starting well along the pathway. The advantages of this are obvious, the obvious reusability, but there's also a nice organization thing. So we only need to use that one reference name to run a whole bunch of instructions over and over again, no matter how many times we need to run them. Or even if we're just going to run them once, we don't necessarily have to reuse them. And just like when data is stored in variables and referenced later, already erased it from the board, we put a 3 in a variable and we use that all over our code. It's like, oh wait, that wasn't supposed to be 3. I meant to put a 7 there. We go back and change that original assignment, and every place we use that variable updates. Same thing with our functions. We might have to do the same thing 10 times, but if we create a reference to it, instead of writing those, repeating those instructions at several spots throughout our program, we can just create that reference, and if we need to update it or fix it, debug it, improve it, any sort of maintenance, we only need to go to that one original spot, and then all the rest of them will update right along with it. So some nice organization advantages, some terms. Terminology that we'll use with this was kind of what I have in the notes here. I've already used both words, I think. So we'll often call them functions and methods. And they're essentially the same thing. The difference between them is where we're using them at. Functions are in procedural programming. And methods are the term for essentially the same thing in object-oriented programming. So they're basically the same thing, and typically in usage, we'll use them interchangeably. and other people who know about programming will know exactly what you're talking about. There is that technicality there that is going to show up on like multiple choice quizzes, certification exams, that sort of thing. So you want to keep that in mind. The same thing, but if we do it in procedural programming, we call it a function, and if it's an object-oriented program, we would call it a method. And pretty much everything we do anymore is in object-oriented programming. There's not really a whole lot of procedural programming left. Fortran's kind of hanging around somewhere in the background. COBOL's long gone. Basic and C moved completely to object-oriented stuff. Lisp still exists, but there's been so many varieties of that made since 1958 that we only use the object-oriented versions of that anymore, like Scheme. So pretty much all of our programming languages that we use in the modern world are object-oriented, so we almost always have methods. But there is that technicality to be aware of, that there are two words that we've used for that. So much akin to how we assign a value to a variable, we define a function. I'll write it up here like a comparison. So assign is the word we use for variables. And we define a function, which kind of means the same thing, right? Assignment in a variable means we're going to put a value into that variable so we can use it later. When we define a function or a method, that means we're putting a bunch of instructions to a reference term so we can use them later. And along with that, we might need some values in order for that function to run. Right, if we're going to do math, we could set up the math in a generic sense, but when we write that reusable code, that reusable set of instructions, we have no idea what numbers actually need calculated come runtime. So we have to set it up in a generic sense, and we create our methods, create with parameters that parameters needed to run, for those instructions to run. I'll phrase it like that. Can't seem to spell today. So we set our method up with parameters that we'll need for the function to run. So if we were going to write a reusable function, hold the instructions to find the sum and difference of two numbers, right? Every time we pass in two numbers, there's some reusable instruction. We call it like sum diff or something. We're going to find the sum and the difference of two numbers, and then we send back what those numbers added together give us and what those numbers subtracted give us. But when we set up those instructions, we need at least placeholders for those instructions to carry out on. We don't know what numbers we're going to add and subtract each time that function gets called, but we set up some parameters, some spots for our data to go. And at runtime, or when we call it, I'll say when using that function or method, when using that method, we send arguments to fill those parameters. So when we set them up, we ask for we ask for parameters and send arguments is one way to sort those two out. This goes into the definition of the instructions, and then when we ask for it, we get arguments. Supposed to have when we ask for it, our term would be call a function. And that just means ask for that function. We want that to run. I'm just gonna write an ask up here because I'm running out of room down in this corner of the board. So mostly going over some terminology before we start looking at these things. Vocabulary is this side of the board. So these words are essentially used interchangeably, but be aware of that technical difference that if we're in object-oriented programming, we have methods instead of functions, because the place where that technicality is going to matter is multiple choice questions on a quiz or a certification exam. So in general, we can just use the words interchangeably and people will know what you're talking about, but there is a technical difference. So the two main types of functions. And this is the standard way to refer to it, because I'm going to add a little caveat on here in just a second of not really, but this is the standard way to say that there's two main types of functions. We have return functions, which calculate or I'll say find a value and send it back to caller. Or we have void functions, which just do stuff. And they don't send anything back. The little caveat there, void is a data type. So actually these return void, but it'll be a while before anybody that's continuing on in programming has to worry about that distinction. Shows up in 248 for sure. I was doing that Monday night, that showed up. 264 definitely makes a difference when we get into asynchronous parallel programming. Asynchronous programming on parallel processors, then we definitely have to worry about that being a data type. But in general, we think of it as two different things. We send something back or we don't send something back. But it's kind of like our space in a sentence, right? To a human, that's just emptiness that that's fine to ignore, but a machine cannot ignore spots. There's not an emptiness to the machine. So that is a type, just like integers and booleans and stuff, but it'll be a while before you have to deal with that. So in general, you can think of it as the two different types. Our function runs through a bunch of instructions, does some calculations, maybe goes and looks things up in a file, but it gets a value and then it sends that value back to whatever asked for it. The caller being other software. User does not count as far as sending stuff back. Void and do stuff, we just do stuff and then we're done. Then it goes back to wherever it was when we asked for that function to be ran. Yeah, so these fill that need of our fourth type, right? We leave the sequence we were in, run this pre-built set of instructions, and then come right back to our sequence where we were. So the invocation. And I'm I'm going to do a couple quick examples on some syntax, just to show you what these are like in both of our things, but mostly it's vocabulary thing using these. You've actually already seen them. We've been using them since just about day one because we didn't start from scratch. We didn't start from scratch in machine language. There was things there ready to use, so we would just ask for them. So what we're doing is we're going to start making those ourselves. We're going to start making those things ourselves so that we don't have to just ask for those things that were already there from somebody else made for us. We can make our own stuff to ask for and fit our personal custom situation better, because the ones built into the language have to be completely generalized to handle any possible situation. But when we get down to that final program version, that script that we're actually going to hand to a user and have them run, we know the details. So we can do a lot better than a completely generalized generic version. Any questions about the terminology? Okay, so some quick examples to glance at. I'll do Python first. So I'll jump over here to this online IDE that I've been using. I really like cloud-based stuff. I'm a huge fan of things on the cloud. Well, y'all have probably noticed it. Whenever I'm doing stuff locally, anything that gets done locally gets put in this folder called delete, which means it's going to be moved to the cloud somewhere as soon as there's a few minutes to do so. I treat machines as disposable. Hardware is just that's just disposable plastic. The data is what matters.
Yes, it is. That is what matters.
Mm-hmm.
And having good backups.
Yes, and if you do it on, the data is on the cloud, then all you need is a way to access the internet, and it's good. Everything's still good to go. So our functions are pre-built things. So our standard example, you probably saw this before even starting programming. The standard example will print hello world. That goes back to in our most people are familiar with that from a Mac commercial back in the mid 1980s, Apple commercial mid 1980s, way before y'all were born. But that was the standard beforehand. Because if we can print a string to our output, we know everything's configured correctly. So that's often just the first step. Just open that up, print hello world, just to check your configuration, because if that runs, you know everything's configured correctly. So that make a good example. Let's make that reusable code, the thing we're looking at today. So I'm going to clear that out of here. And in Python, what we want to define a function. So our keyword or abbreviation of a word is the abbreviation of the word define, right? Def for define. I usually go ahead and say define when I say it, whenever I read that word. But we'll define a function, and I'll just call it say hi. To do that, print the words hello world to the screen. That way we can use that over and over and over again. So some things you've probably seen with Python. Now that we've looked at a little of it, I'll point out what I like to think of as the general syntax of Python. We have a keyword followed by something unique to our situation. Whoops. Then a colon, and then we indent everything that goes with it. Kind of like those selection structures we saw, right? If X is bigger than 37, and big, I don't know, some random example there. Don't have what X is, but we have that keyword, the part that's unique for our situation, a colon, and then everything that goes with that selection or that branch of the selection structure gets indented. That's what I like to point out is the general the general syntax, general Python syntax is what I call it. So keyword to create a function is define, and it's abbreviated because Python was created back in the late 1980s when RAM was a very precious commodity. So we certainly didn't want to waste RAM on computer experts that would be working in Python. So everything was abbreviated back then. We needed the RAM for the end users. So that took this instruction and just kind of put it to this word. So I made a comment about those two types. So we have return functions and void functions. What do y'all think this is? Is this a return function or a void function?
A return function?
I like to ask this question because most people get this wrong at first. The human does not count. So we're sending something to the human, right? And then afterwards, there's nothing to go back to software.
Oh,
So
it is void.
this counts as a void function.
Huh. Okay. So nothing comes back.
Yes. When we talk about that interaction, and as you progress further, you will find other pieces of software often get referred to as user, because this other software is what's using our software. So other software is what counts in that passing things. So our print statement, which passes stuff out to the human, it does not count as a return because it's not coming back to software. And then to call a function, all we have to do is ask for the name of it. Actually, I'm going to do this a couple ways. I can do it in the shell. I define that function. So when I run this, it looks like nothing happened. Did that run? Oh, so there, when I just put the words in.
Mine isn't running either.
Huh? Oh, because it doesn't do anything. All we did was define a function. We never asked for it. So at this point, when I hit run, it went through this code and said, okay, there's a function called say hi that's been defined, but we never ask it to run that function. We just defined it. It's defined to use later. And notice when I type just the words here, it says, okay, there's a function, has this reference value at this spot in memory. That's where it's stored at. To run it, we need those parentheses. When I use that reference value and then add some parentheses afterwards, now you can see it goes through and runs those instructions. Did yours work that time? With parentheses?
Well, it's telling me my internet connection is unstable, so I'm giving it a second.
Oh, okay. Yeah, that happens too. So
I should have Python on here, honestly, for that reason.
So you can see that it is a reference value, right? When we have just a word, that's our variable. That's storing something. So what we're storing is a function, a set of instructions. And technically, in case this ever shows up on a multiple choice quiz, Python is only object oriented. So we don't actually have functions in Python. We have methods. So even the people that know enough about computers to put this together still use those words interchangeably. But when you go to take certification exams and multiple choice quizzes, remember methods go with object-oriented programming and functions go with procedural programming. So I was just printing that out there. We would use that over here. So to ask for the function, we just like we did whenever we stored stuff in a variable name, we just put it on there. And if we want to actually run the function, include the parentheses. The way I like to say it is our general syntax across multiple languages is to store something it's just a word. That's a variable. Do something or a function, that's a word and then parentheses. And the parentheses mean do something. So now we can do that repeatedly. We can call say hi over and over and over again. And when we run it, it should print out all of those. Every time we put this, it's going to run that instruction. So for one line, it looked like it added a little bit more. So we probably usually want more than one line there. Another simple example might be to double a number. I'm going to say double some number. And well, this is that situation we were talking about earlier. We're going to do some math. We want twice as much as a number. So we need to know what that number is. But that's going to vary every time we ask for whatever double a number is, right? So we need a parameter to put that number in. So I'll put sort of it's like a variable, but it has smaller scope. So I'm going to create a little variable. I'll call it number here, that inside of those parentheses, and that's a parameter. It doesn't exist through the whole program. It's only going to exist in this function we're defining, but it gives us a place to send a number to. So later when we ask for this function, we'll fill that parameter with an argument, and that will be a number, and then it can do stuff with it. So we have another keyword. Well, I'll set it in a variable, do some math. Doubling that number is 2 times the number. And once we have that, we want to return that. And again, we have another keyword, just return. So send back whatever I called that, double it. You can see multiple lines of function or multiple lines of instructions. In this case, just 2, but the bare minimum, it should build up in the obvious manner from that. 2, 3 is exactly the same, just indent everything. And if you're done with the function, just kind of stop doing the indenting and come back over. When the cursor comes back over, like unindents, that's when the function's done. It can be a little hard to see sometimes, so it's not a terrible idea to label the end of your function. In some of our other languages, we would have a curly brace there. Like a colon and indenting takes the place of the opening and closing curly brace. So those curly braces could end up a long way from any of our keywords. And it's easy to get lost in those. Even more so in Python, where we have white space. So to help keep things straight, it doesn't hurt to label the end. You can just put a little comment at the end in say hi. Just a useful little thing so you don't lose track of where the indenting is supposed to stop. The end of the function. So then we'll run that, and same thing down here. Whoops, that's not a comment symbol. End of the double function, which is just a comment. It doesn't have to, it's code that doesn't do anything. We probably won't, we won't see it this class, but comments are text in here that the interpreter will ignore. So the interpreter will ignore things that we put this symbol on. It'll ignore the text for the rest of that line and only read the Python code. So it shouldn't take very much thought at all to realize that we could also have the computer ignore the Python code and only look at that. So then we can do more than one thing in one script. Typically, we do things like generate websites, documentation, things like that. But we won't see that this class. So just a quick pass on introducing the functions. Then when we need to run that, we'll just say double and pass in some sort of argument to fill that parameter we set up. Run this, but it didn't print or anything, right? If I did that here, it would work. So after we run all those functions we defined, they're loaded into the interpreter. The interpreter knows about them. So over here, we would need to put that somewhere. So whenever you have a return function, which I asked that question earlier because it's a lot more obvious when we see that keyword return there. Whenever something gets sent back, we have to put it somewhere. So say X is twice as much as 4, and then it can print out X. So a question popped up in the chat room. Is there no way to delete the white space, like press enter too many times? I think what that's referring to is like here at the end of the function. I'll do it on this one. If I push enter, this text editor knows Python stuff has that important indents. So it keeps everything. If you need, you can just hit backspace to get back out. Or if you come down and do that a lot, you can just highlight through there and just use the backspace or delete keys and or arrows and just kind of remove that text. It's there automatically. Notice that won't happen here after return when I hit enter. Oh, well, this isn't a good one. Most of them that know Python after that return, we can't do anything else after the return statement. So it will automatically go back afterwards. This one I'm typing on apparently doesn't do that. But that's our basic syntax. Keyword define, DEF for define, a name that fits our situation, a useful name so that you'll remember what that is or kind of summarizes what it does. If we need to pass in parameters, I'll do one more to show multiple parameters. Define add X and Y, because if we're going to add stuff, we need two numbers, right? Then we'll print the result of X plus Y. Then if I call add with 2 and 3, notice it's just a comma separated list if there's more than one parameter needed. And then we do comma separated arguments to fill those parameters. Oh, over here, sorry, I misunderstood the question. The question in the chat room is, so in the interpreter, no, we cannot get back. That is a instruction that runs. That's a shell. So that's kind of like when we're actually running instructions on our machine. What do I have here? I have terminal. So if I open up I didn't want PowerShell. We're going to look at PowerShell soon. That's a useful one. If I open up my bash shell to run my machine, so I could like, well, we talked about clicking on pictures the other day, right? The stuff on the screen is just pictures where we click with our mouse. And when we do that, it runs an instruction in the background. So I could run those instructions directly myself, switch over to the documents / delete folder and make a directory called test. Then if I list out we'll see that new directory is there somewhere. So the shell is kind of like this. It's a place where the instruction runs. And when we hit enter in a shell, if there's nothing in that line, really all we're doing there is running a void instruction, right? We said run this instruction, but then we didn't give it anything. So the computer's like, okay, done. And then it popped up the place to run the next instruction. So in the interpreter shell is kind of the same thing. We can't get back to the previous one. Sorry, I misunderstood the question at first. So that's our Python syntax. And obviously we can do this in Raptor as well, but looks like it's a good time for a break, right? 2:28. That's what I was thinking. The Python example would make a good spot to split up a break, and then we'll look at this stuff in other places. To 10 minutes sound good to everybody?
Sounds good to me.
Sounds
Okay,
good.
so-
Have fun.
2:29, we'll get back to it at 2:39. I'm gonna go grab some coffee and I will see y'all in just a moment.